Hello and welcome back to another lesson for Math 7. Today we're going to do lesson 102, so it's for Tuesday. Now I'm going to do a little bit something different than what I've been doing so far, and it's I'm going to record the next 4 lessons together so that it's easier for me. So I don't know what's going to happen about anything that's going on. So I meant in school. Obviously, I know what's going on in math. Duh. And so, yeah, that's what I'm going to do. So we're going to do lesson 102, which is transversal and simplified equations. Again, it's one of those lessons that I don't understand how the book combines two things that actually are pretty important. But they kind of just put them together like, oh, yeah, these are not very important. Let's just put them together. So I'm going to start with the second part. Simplifying equations, because the simplifying equations part has to do with combining like terms and the distributive property. And then I'm going to jump into transversals, which is something that has to do with geometry. So I don't understand why your book does this. It's one of those things that I like your book for the most part, but this type of lessons drive me a little bit crazy because this is an important lesson for both parts, for both transversals and for simplifying equations. So I'm going to jump into example 3, I believe. Yeah, so I'm going to do 3, 4, 5, and then I'm going to go back to 1 and 2, okay? Just so that people understand what I'm doing, and people are not like, oh, what are you doing, Mr. Silva? I'm so confused, okay? So, yeah, let's get right in. Okay, and in example 3, we have 3x plus 5 minus x equals 17 plus x minus x. So the first thing that we have to understand is the coefficients, right? The coefficients. So we have to remember this word coefficient. I'm going to write it right here. Coefficient is one of two things that all variables have. The first thing is that they all have coefficients, and the second thing they all have are exponents. Hopefully I don't have to go over exponents, but pretty quickly it's going to be the numbers that we are raising the variable or letter to. So all variables or letters have exponents. Now coefficients. What are coefficients? Coefficients are the numbers in front of variables. Do all variables have coefficients? Absolutely 100% they all do. So in here the coefficient is 3 for x. That's pretty easy, right? In here, though, what is the coefficient? I don't see it. When you don't see the coefficient, remember that it's 1. But watch out, though. This is not just a 1. This is a negative 1 because of the negative here. Okay? And here, then, we have a coefficient of 1. And in here, we have a coefficient of negative 1. And then we have the constants. And that's one of the reasons I underline it is because, hopefully some of you already saw it, I'm going to combine like terms. And so let's combine like terms. I'm going to put the 3x and the negative x. I'm not even going to do any math right now, okay? I'm just going to combine the like terms. And in the second one, in the second part, I mean, to the right, they already put the like terms together for us. How nice of them, right? And so in here we have 3x minus x. A lot of people might say 3x minus x, oh, it's just going to be 3 and the x, like, cancel each other. No. The coefficient is negative 1. What is 3 minus 1? Or 3 plus negative 1? Same thing. 3 minus 1 is going to be 2, so we're left with 2x. Oh, okay. Plus 5 equals 17. And what is 1 minus 1? 1 minus 1 is 0. So 0x is going to be 0 because everything that you multiply times 0 is going to be 0. So we get 2x plus 5 equals 17. Okay, so then we're going to switch over to the other side by subtracting the 5 on both sides. And then we get 0. And in here we get a 12. And so we get 2x equals 12. And then we divide by 2. Both sides. We just bring down the 2x here. when we divide by 2, we're going to get x equals 6. And that would be our answer for the first example, x equals 6. I'm going to keep this word here, coefficient. The exponent one, I'm probably going to remove for the next example. But it's really important for us to always keep in mind the coefficients when we're trying to solve a problem that has variables in both the left and the right. And obviously, we have to solve for x. All right, in example 2, really easy. Oh, I told you I was going to erase exponents, so I'm going to do it right now because I forgot. All right, so we have 5x minus 17 equals 2x minus 5. In here, the 5x and the 2x are like terms, right? And the negative 17 and the negative 5 are constants. And so they're like terms too. So what we have to do is get the 5x and the 2x together. However, rule of thumb for problems like this, please always move from the least amount of x to the most amount of x. What do I mean by this? Or the least amount of a variable to the most. Okay, so because we have 2 here and 5 here, I'm going to move from the right, the 2x, I'm going to move it to the 5x because I always want to leave my variable to be positive, okay? It makes it way easier to solve. It just makes it way easier if I move it from the least amount of x to the most amount of x, or from less x to more x, all right? And so what I'm going to do, because it's positive here, positive 2x, obviously is positive, I'm going to subtract 2x from both sides, and it's going to be 3x minus 17 equals negative 5. Okay, don't forget that just because you subtract it here, it'll be 0, but then because 2x minus 2x is 0, and 5x minus 2x is 3x, because 5 minus 2 is 3, right? And so then I have to move the 17 over here, and to move it, I have to add 17 on both sides. So in here would be 0, so it's 3x plus 0 equals, what is 17? Negative 5 plus 17. Remember, if you're having problems with adding and subtracting integers, use the number line. But what I'm going to actually ask you to do in here is, because the 17 is positive and the 5 is negative, do 17 minus 5, which is really easy because then it would be 12, positive 12. And so I end up with 3x equals 12. Then I divide by 3 on both sides, and then I get x equals 4. And that is how you solve the fourth example. I was going to say the second example, but remember, I told you that this lesson was a little bit weird. I didn't like it, and I think that this is not as easy as I'm looking at, as I'm making it look, because I've been practicing for so long doing this type of math. It looks easy when I do it, but I know that some of you, when you're going to do it, you're going to be a little bit confused. And so I wish that they just gave you even more examples and more things to practice with. But unfortunately, that's what the book did. So that would be the end of example 4. All right, so in here, we're not only going to have to combine like terms, we also have to do the distributive property. So distributive property, if you remember, is when you multiply the 2 times the x and the 2 times the negative 4, okay? So that's the first step. Always do distributive property. You have to. It's like the new order of PEMDAS. All right, and so we have 3x plus 2 times x is 2x. 2 times negative 4 is going to be minus 8 equals 32. Well, in here, the 3x and the 2x are alike. So I'm going to combine those two terms. And look at that. It's nice for us because they're right next to each other. But the negative 8 and the 32 are alike, and I need to move the negative 8 over here. So I'm going to add 8 on both sides. And you know that this side becomes 40, and in here, 0, right? I'm not going to write the 0. I hope that you already know that in here I have the 0. Then 3x plus 2x. What is 3 plus 2? 3 plus 2 is 5. So I get 5x equals 40. Then I'm going to divide by 5 on both sides like this. 5x divided by 5 and 40 divided by 5. And so I'm going to get x equals 8. And that's how you do it. Now, a quick reminder for everybody that wants to understand how to check your answer. The way to check my answer is if I got the x, and this happens to be true for example 5, example 4, and example 3. So all the 3 examples that we just looked at, what we're going to do is we're going to put the 8 in here instead of the x. So I'm going to put 3 times 8 plus 2 times 8 minus 4 equals 32. And then you just multiply. 3 times 8 is going to be 24 plus 2 times 8 minus 4 is going to be 4 equals 32. And 2 times 4 is going to be 8. So 24 plus 8 is going to be 32. 24 plus 8 is going to be 32. So 32 is 32. Oh, look at that. I checked, and so that's right. So if you ever want to check, you just put whatever you put in x, in the value that you have for x, you put it in the beginning of the, at the beginning of the problem, you put that number instead of the x, and that is how you check. And that would be it for the algebra part of this lesson. The algebra part means the one with the letters and the numbers. Now we're going to go into the lines, which is the geometry part of the lesson, and that is transversals. Okay, so I actually already talked about transversals. So transversals are lines that actually intersect others. That is, and it doesn't matter how they intersect them, all right? But transversals usually have to do with parallel lines. So I'm going to say that line L and line M are parallel lines, and line T is the transversal of both line L and line M. I'm pretty sure I went over this before, but because it was a long time ago, I don't even remember what it was, that we needed to understand the interior angles inside. Remember, interior inside, exterior outside, and then we have the transversal angles, A, D, E, H are transversal to each other, and G, F, C, B. Not that they are transversal to each other, but A, D are transversal, G, F are transversal, H, E are transversal, D, C, B are transversal, okay? So that is transversal. So what are we going to do? Well, in example 1, it says that transversal T intersects the parallel lines L and M so that the measurement of angle A, so they tell us the measurement of angle A is 105 degrees. And now they tell us, well, find the other ones, right? Find the measures of B through H. Exactly. So I have to find angle B, angle C, angle D, angle E, angle F, angle G, and angle H. Wow, that looks like a lot of angles that I have to look at. But if you just remember what I told you about transversal angles, A, D, E, H are transversals, but also they are congruent. Congruent means they measure the same, but they're not the same angle because angle E is not the same as angle H. Angle E is on top, angle H is on the bottom of line M. And then in line L, A and D are different positions, but they're the same measurement. And so I already know what D is, because if A is 105 degrees, then D has to be 105 degrees because of transversal angles. And then if E is 105 degrees, then H has to be 105 degrees. Look at that. It looks a lot less difficult because we already did 3 of the 7 angles we had to do. Now we still have to do 4, but I have good news for you. The 4 are actually transversal angles. G, F, C, B are transversal angles. You see, B, C, F, G, B, C, F, G are transversal angles. So if you find the measurement of one of the angles, boom, you found the measurement of all the angles. So it's actually pretty easy. So how are we going to find that? Well, we're going to know that A and B, right? Angle A plus angle B are going to make a straight angle. And the straight angle measures 180 degrees. That's why it's always really important for us to remember that. So I'm going to put 180 degrees here because it's a straight angle minus 105 degrees. And I hope by now some of you already know this answer is going to be 75 degrees. Look at that. So 75 degrees is going to be angle B, the measurement of angle C, the measurement of angle F, and the measurement of angle G. They all are going to measure 75 degrees. And so it's going to be 105 degrees, 75 degrees, 75 degrees, 105 degrees, 105 degrees, 75 degrees, 75 degrees, and 105 degrees. How do we do that? By understanding that the straight angle has 180 degrees, or a straight line has 180 degrees, because L is a straight line, even though, it might not be super straight in the drawing here, but it is. And that's how you find how it is. That's it. All right, and finally, example 2. I know that I said example 2 instead of example 5, but I told you this is a kind of weird lesson. And so we have already discussed exterior and interior angles. So exterior means outside, the exits outside, and interior means the insides. But then we also have corresponding angles, and they say, name 4 pairs of corresponding angles. Okay, so corresponding angles, what are they? Corresponding angles means, well, you see right here we have 4 angles. Well, we have 4 angles right here too. And so they're saying in the position of the 1, right here of angle 1, which angle in here is in that position that angle 1 was? Oh, that's pretty easy. It's angle 5. So what you have to do is do angle 1 and angle 5 are corresponding, because they correspond from the position. Literally, it's just the position where they are. This was going to be the first one on the top left, and this one is the first on the top left. Well, in the top right, I have 2 and 6. So angle 2 and angle 6 are going to be corresponding angles. And then I have angle 3 and angle 7 being corresponding. Angle 3 and angle 7. And finally, I have angle 4 and angle 8. Angle 4 and angle 8. And that's it. Those are my 4 pairs of corresponding angles. Now, alternate exterior angles. What are exterior? Exterior means the outside of the whole thing. So the outside has to be either angles 1, 2, and 8, and 7. Okay? But what are alternate? And there's only 2 pairs of alternate angles. Alternate means opposite. All right, so opposite, alternate. When we tell you alternate your foot, it means opposite foot. Or alternate your hands. If you're playing basketball and you're dribbling with your right, you have to start dribbling with your left. So alternate means opposite. So what happens is that in math, we do the same thing. We use the same terms. Alternate means if you're dribbling with your right foot, you then have to switch to your left foot. And what the alternate exterior angles mean is the opposite angle that it's on the outside. So it's going to be 1 and 7. Angle 1 and 7 are going to be alternate exterior angles, and 2 and 8. Because the 2 is in the bottom and the 8 is kind of on the top, quote unquote. And because the 7 is in the bottom and the 1 is on the top. That's why they are alternate. So angle 2 and angle 8. Those are the alternate exterior angles, and then interior means on the inside. Okay? So then that one's pretty easy because it would be 4 and 6 and 5 and 3. 4 is opposite 6 and 5 is opposite 3. That's what I was telling you the alternate is. And so it's going to be angle 4 and angle 6 and then angle 3 and angle 5? Yes, angle 5. And that would be it for example number 2. And this is it for lesson 102, which is a little bit important, I think. And unfortunately for you, we are going to get into a little bit harder stuff as we move on into the lessons. I think lesson 106 is going to be slope or something like that, which is super important for algebra. And then lesson 116, I think it is, we're going to do form of a line that's called slope-intercept form of a line. And again, I don't know what's going to happen to the schools, but hopefully at some point maybe I can explain this to you in person, but I don't know. But anyway, thank you for tuning in. Thank you for liking, commenting, subscribing. Keep it up. I have over 30 subscribers now. Wow, it's crazy. And so, yeah, it's just, I'll see you in the next one.